Welcome to Methamphetamine. Today we're gonna do the integral of e power of arcsinx from -1 to 1, or you can pronounce it as inverse sine. Let me pronounce it as inverse sine x here. And you see the integral from -1 to 1. I recommend to check either this an R function or an even function or neither. To check this, you can put -x inside because inverse x is an R function, so you can put a negative sign outside. You can negative inverse x, but the whole function is e power of psi x, right? We don't have a negative here, so it's neither. It's neither an R function or even function. So let's continue to do this integral. Let me use our substitution. We let u is equal to r psi x inverse x. And du, what's the derivative of inverse x? This is 1 over square root of 1 minus x squared. You can check it. But let y is equal to sine inverse sine x. And then the original is sine y is equal to x. And you can do the derivative and you get this at the end. So what's our dx? Dx is equal to square root of 1 minus, and what is x here? Because u is equal to inverse x, so the original is sine u is equal to x. And then you square both sides, so you can get x squared is equal to sine square u. So this is sine square u du. So 1 minus sine square u is cosine square u, and then take a square root, you get cosine u du here. So you can replace this with e power of u cosine u du. And to figure out what our upper limit and lower limit, just put -1 inside. As inverse sine of -1 is negative pi over 2. Inverse sine of 1 is pi over 2, right? And here we don't need to check either this is an R function or even function. Just keep doing, because if the original neither R function or even function, then the substitution function won't be the R function or even function either. So don't need to check it. So how to integrate? And this is a very popular integrals. The integral of e power of something and the sine and cosine, right? And tangent is impossible. E power of x tangent x is impossible. I don't know. I think this is an elementary, but I think this is impossible because if you use the integration by part, you get e power of x, e power of x, e power of x, the derivative, and then the integrate you get. The next is L1 epsilon of secant x, and to integrate L1 epsilon of secant x is impossible, I think. So let's continue. So to do this derivative, to do this integral, not derivative, we're gonna use the integration by part. Put a d and I. We're gonna differentiate e power of u and then integrate cosine u. Keep differentiating e power of u, you get e to the u, e power of u, and you get sine u. To integrate sine u, you get negative cosine u here. So this time that you get e power of u sine u, and then we're gonna put the upper limit and lower limit. Then e power of u times this, you get plus e power of u cosine u plus this. And then the final one is this one, minus the integral of e power of u cosine u, and then from negative pi over 2 to pi over 2 du. So you can put it to the left hand side, it becomes 2 times the integral of e power of u cosine u du from negative pi over 2 to positive pi over 2. And then this one, let me do this in our head. If you put pi over 2 into it, you get e power of pi over 2. And then if you put pi over 2 into psi u, you get psi pi over 2. And this is 1. So you get the first one is e power of pi over 2. And then you're going to subtract e power of negative pi over 2. And then psi negative pi over 2, you can throw the negative in front so you can get positive here. And then the next one is this. If you put pi over 2 into cosine u, you just get 0. And this is entire just 0, add 0, and then subtract. If you put cosine u and if you put negative pi over 2 into cosine, you can get 0. So this is also 0. So the final answer is the integral of e power of u cosine u from negative pi over 2 to positive pi over 2, you get e power of pi over 2 plus e power of negative pi over 2 over 2. And what's the point of this? E power of pi over 2 plus e power of negative pi over 2 over 2. And this is our hyperbolic cosine or cos pi over 2. This is really cool. This is our final answers. Cos pi over 2. And if we use the calculator, if I use the calculator to figure out these answers, and let me figure it out. Hyperbolic cosine pi over 2. And you get this number. This very closer to be 2.50917 or something. And that's our final answers. Cos pi over 2. Very beautiful.